Today, we are diving deep into one of the most fascinating and controversial unmanned aerial systems ever developed. A weapon that doesn't just fly, but waits, watches, listens, and then strikes with surgical precision. The Harop Loitering Munition, built by Israel Aerospace Industries, is not just a drone or a missile, but a hybrid of both. A hunter in the sky that patiently waits for the perfect moment to destroy its target. This is not just a machine. It's a silent, floating presence above the battlefield, almost like a ghost, and it changes everything we thought we knew about modern warfare. So let's explore how it works, why it's feared, how it hunts, and what it means for the future of autonomous combat. The Harop is what experts call a loitering munition. That means it's designed to roam the sky for long hours, searching for a target. It doesn't need to be manned. It doesn't need to return to base. Once launched, it waits, it watches, and when it finds a threat, it dives straight into it, destroying both target and itself in one final strike. Imagine a drone that isn't just collecting intelligence, but one that's actually the weapon itself. No bombs to drop, no missiles attached. It is the missile, it is the hunter, and that's what makes it so unique. From the outside, the Harop looks like a small, sleek aircraft with delta-shaped wings and a rear propeller. It has a streamlined shape for silent flight, making it hard to detect. It's compact, but don't let its size deceive you. It carries a deadly warhead capable of destroying radar systems, missile launchers, command posts, armored vehicles, and other critical targets. What makes it different from conventional drones is simple. Traditional drones spot the target, then someone else fires a missile. But Harop breaks that chain. It is both the eye and the fist. But here's where things get even more interesting. This drone doesn't just use GPS or remote control. It can detect enemy radar signals by itself, meaning when enemy radar starts to search the sky, Harop listens. It finds it, it locks onto it, and without waiting for human approval, it can autonomously dive into the signal source and destroy the radar. It is literally drawn to electronic signals, which is why it's sometimes called an anti-radiation loitering munition. Now think about what this means on the battlefield. Radar is one of the most important assets in any military. It warns of incoming missiles, bombers, and drone attacks. But when Harop is in the sky, switching on radar could be a death sentence. The moment it detects that radio wave, it becomes a beacon, silently calling the Harop to strike. That creates fear. It creates silence, and in modern warfare, silence means blindness. When the Harop hunts, it can stay airborne for up to 6 hours, depending on mission configuration, and cover hundreds of kilometers. It can be launched from ground vehicles, aircraft, ships, or even simple portable launchers. It doesn't need a runway. It doesn't need a big launcher, just a catapult-like system, and it's airborne, ready to hunt. Once it's flying, operators can control it through a datal, ink, or let it hunt autonomously. It carries advanced electro-optical and infrared sensors, which means it can track targets day or night, in clouds, dust, or even smoke. But here's something fascinating. Even after it finds a target, even after it's diving toward it, the operator can still abort the mission. That's right. It's a suicide drone, but it doesn't have to commit suicide. It can pull back, circle again, and wait for a better moment. That level of control is incredibly rare in kamikaze-type systems. Its warhead weighs around 23 kilograms, powerful enough to destroy radar antennas, missile batteries, and vehicles. But it's not just about size or speed. It's about precision, timing, and psychological warfare. The Harop has been used in real conflicts, most notably in the Nagorno, Karabakh War between Azerbaijan and Armenia. There, it proved exactly how effective and terrifying it can be. Videos released from that conflict showed Harops circling above the battlefield, silently stalking targets. Then, in a single moment, it would dip its nose and dive like a falcon, slamming into a radar truck or artillery unit and blowing it to pieces. Those strikes were fast, precise, and hard to stop. Soldiers couldn't hear it coming, they couldn't shoot it down. They couldn't hide from it. Watching those videos, you don't just see destruction, you see a new kind of warfare. One where machines don't just collect data, but make decisions. They don't just follow orders, they hunt. Let's imagine how an enemy experiences it. A radar operator is sitting in his station. The radar is active, scanning the skies. Suddenly, an unknown electronic signature appears. The Harop has found the signal. In seconds, it locks on. And then, without warning, somewhere in the sky, a quiet little drone tucks its wings and dives. It's silent. It's fast, and by the time the radar picks it up, it's already too late. That's psychological warfare. Making the enemy fear the air, fear their own radar, fear switching the machines on. This is why Harop is more than a drone. It's a strategic weapon. A weapon that targets infrastructure, technology, and morale all at once. From a technical perspective, Harop has a wingspan of around 3 meters, and it weighs about 135 kilograms. Not too big, but not too small either, just large enough to carry sensors, fuel, and explosives. It uses a pusher-style propeller in the rear, reducing its acoustic signature. That means it's hard to hear. When it flies at medium altitudes, it's almost impossible to spot without advanced detection systems. One of the most powerful features of Harop is its autonomy. While an operator can control it, it doesn't need constant guidance. It can identify targets, follow signals, and even strike without manual input based on its programming and mission types. But with that comes ethical questions. Should machines be allowed to decide when to kill? Is that the future? Are we comfortable giving that responsibility to AI? Harop sits in a gray zone. It's not fully autonomous. It still gives humans the final control, but it's getting close. And that's what makes it so important in discussions about future warfare. And it's not just Israel using this technology. Harop is reportedly used in India, Germany, South Korea, Turkey, Azerbaijan, and several other nations. Some even believe that newer variants can swarm, meaning multiple Harops can work together, sharing target information, hunting in packs like wolves in the sky. Imagine that, not one hunter, not two, but dozens of small, silent drones flying in formation, waiting for electronic signatures, ready to strike with perfect timing. That's what the future of warfare looks like: swarms, information, electronic warfare, machines talking to each other. The Harop proves that the battlefield is changing. No longer is it about tanks rolling forward, or jets screaming through the sky. It's about silent machines waiting, thinking, striking. Harop's unique design allows it to loiter at high altitude, far beyond enemy detection, while its onboard sensors scan for heat, movement, and radio signals. It's a patient hunter. It doesn't rush, it waits, and that waiting is what makes it so dangerous, because when it strikes at the most vulnerable moment. One thing that makes Harop truly innovative is that it is disposable but not dumb. Each mission is one way. It won't return, but before it dives, it collects valuable intelligence. It sends images, feeds, and signals back to its operator. It helps not only attack, but understand the battlefield. That turns each Harop from a weapon into a sensor platform. And in modern warfare, information is everything. Some compare it to other loitering munitions, like the American Switchblade or the Russian Lancet. But Harop is different. It's bigger, smarter, and designed not to hunt soldiers, but use strategic assets like radar, communication units, mobile missile batteries, and command centers. It doesn't destroy armies, it destroys their eyes and ears. That's why it's sometimes called a seed weapon, suppression of enemy air defenses. It cleans the battlefield, it removes threats, and once those threats are gone, it becomes safe for manned aircraft to fly. That's strategic warfare. One of the most impressive things about Harop is that it doesn't need satellite communication. It can find and attack targets based on their electronic emissions alone. That means even in jamming environments, where GPS and data links are blocked, Harop can still hunt. That is a huge advantage. In a world where electronic warfare is becoming common, the ability to operate without GPS or constant control is a big deal. In many ways, Harop is a bridge between drones and missiles, between surveillance and attack, between control and autonomy. It is a hybrid weapon, and hybrid users win hybrid wars. Future variants may even carry AI-based targeting, allowing them to identify objects based on shape, heat signature, or movement patterns. It could recognize a tank, a radar unit, or a mobile command vehicle, and decide whether it's worth striking. That's not science fiction. That's a direction we are already heading toward. War is changing. It's getting smarter, quieter, more precise, more automated. And Harop is one of the first steps into that future. Some worry that these machines could one day make decisions without humans. That they could hunt not just machines, but people. That warfare could become automated. And while Harop still requires human approval for final strike decisions, it represents a shift in mindset. A move toward a future where human presence is further away from the battlefield and machines are closer to the destruction. And that opens a debate. Do humans become safer in war, or does war become easier to start? Because when machines do the fighting, politicians might be more willing to let them. But for now, Harop is a tool, a powerful, strategic, intelligent tool. It is a guardian for the attacker and a nightmare for the defender. It tells us that the sky is no longer just a place for aircraft. It's now a place for hunters that wait, circle, and decide. Harop is not just about destruction. It's about control, pressure, and psychological impact. When it's in the air, enemies don't know if they're being watched. They don't know if they're being targeted, and that fear shapes decisions. It forces radar operators to turn off their equipment. It silences communication networks. It disrupts command and control. A silent drone can sometimes do more damage than a loud missile. And that is why the Harop is considered one of the most effective loitering munitions in the world. It proved that sometimes victory doesn't come from brute force, but from patience, precision, and silence. And now, as newer versions are being developed, with longer range, smarter targeting, and even swarm capabilities, the question becomes, what's next? If machines can wait, think, and strike, what will future wars look like? Will they be fought by humans, or by autonomous hunters flying in the sky? The Harop Loitering Munition isn't just a weapon, it's a warning, a sign of what's coming. A future where the battlefield is digital, autonomous, intelligent, and silent. And when silence becomes a weapon, fear becomes a strategy. So next time you look up at the calm sky, remember, somewhere up there, a machine may be waiting, watching, and listening. Because war no longer shouts. Sometimes it whispers, and that whisper can strike. Thank you for being here today, for exploring this fascinating and chilling machine. The Harop Loitering Munition shows us how far technology has come, and how much further it will go. As warfare evolves, we must ask, are we ready for a world where machines learn to hunt? Until next time, stay curious, stay aware, and remember, the future of warfare may not roar like thunder. It may glide like a shadow, wait in silence, and then strike with precision.